Okay, today we're starting chapter 9, which is on stoichiometry. We'll be doing lots and lots of conversions, but really we've done most of them last semester when we did conversions between moles and grams to moles. We're using that same conversion, but we're going to add a different one with the mole to mole ratio. So we're going to use mole to mole ratios using our balanced equations. There's two types of stoichiometry. Composition stoichiometry is the mass relationships of elements in the compound. Like when we found percent composition, we were taking the mass of the element over the mass of the compound. That gave us the composition, percent composition, or the composition stoichiometry. That's that process. This chapter, we're going to be looking at reaction stoichiometry, the mass relationship between reactants and products. It doesn't have to be a reactant and a product in the problem. It could be two reactants, two products, as long as it'll just be two different compounds in that reaction. We're looking at the mass or mole of those compounds. So you always have to use ratios from balanced equations. So you always have to have a balanced equation in order to convert from moles of one to moles of another compound. And there's 4 different types. We're going to learn about types 1 and 2 today, and then we'll do 3 and 4 tomorrow. But the type 1 is that the given and unknown quantities are in moles. So that it might say you have, like the electrolysis of water is H2O yields H2 plus O2. So we have, if you have 2 moles of water, how many moles of oxygen gas would you get? That would be that kind of problem. Problem type 2 is if you had 2 moles of water, how many grams of oxygen do you get? So your unknown is in grams. Type 3 would be if I have 2 grams of water, how many moles of oxygen would I produce? And then type 4 is if I have 2 grams of water, how many grams of oxygen gas do I produce? So you're going from grams to grams. But really, whenever we do these kind of problems, we're using just 2 ratios. We're going to use our molar mass ratio and a mole to mole ratio. So the mole ratio, we're using our coefficients from the balanced equation, because if we read this, we can read it as 2 moles of aluminum oxide yields 4 moles of aluminum plus 3 moles of oxygen gas. That's one way we can read it. And the moles of aluminum, then we can say, instead of 2 moles of aluminum, what if I have 13 moles of aluminum oxide instead of 2? How many moles of aluminum will I get now? And to do that, you'd start with the 13 moles of aluminum oxide. And you use your coefficients. So for every 2 aluminum oxides, I produce 4 aluminums. So for 2 moles of aluminum oxide, I produce 4 moles of aluminum. So we're using our coefficients as a mole ratio. So in this case, 4 divided by 2 is just 2. So we would get an answer of 26 moles of aluminum. But that's how we use our mole ratio. Whenever you convert from one compound to another, both units have to be moles. You cannot convert from moles of one compound to grams of a different compound in one step. You have to be in moles for both. So you're going to use your mole ratio first, and then you can do the next step, which we'll learn in problem type 2. We can do another step with that and change moles of aluminum into grams of aluminum. But you still have to do the mole to mole ratio, okay? That's one place where people mess up, is where they are trying to do moles to grams of different compounds in the same step. Whenever you change compounds, both units have to be moles. Molar mass, we've used molar mass before when we convert just the mass of the compound into the moles of that same compound. And where do you find the molar mass? Periodic table. And how would you find the molar mass of aluminum oxide? Right. 2 times aluminum plus 3 times oxygen. And that's always the mass of 1 mole of substance, the mass in grams. So if I have 26 grams or 26 moles of aluminum, which really is the answer from our last slide, right? We would have 1 mole of aluminum on the bottom and then 26.98 grams of aluminum on top. So this step could be right here, this molar mass step could be added on to the end of our problem on that previous side. And that would be a different kind of problem, the problem type 2. And so you'd multiply, and we don't have to do that right now. Okay, so we're going to use those 2 conversions. Well, actually, in problem type 1, we just use the mole ratio because it's a mole-to-mole problem. We're given moles. We're just converting to moles. We don't have to do anything with grams. So we just use the one conversion factor, the mole ratio. The mole ratio comes from the coefficients. So always in this equation and always check to make sure it's balanced. So in a spacecraft, the carbon dioxide exhaled by astronauts can be removed by its reaction with lithium hydroxide according to the following chemical equation. Is it balanced? Well, we have 1 carbon on each side. How many oxygens on the left? Yep. There's 4 oxygens on the left, and there's 4 on the right. Because there's a coefficient of 2 here, remember? So there's 2 oxygens plus 2 oxygens. There's 2 lithiums and 2 lithiums, and then 2 hydrogens and 2 hydrogens. Yep, it is balanced. So what I like to do is as I read under my balanced equation, I like to write the information that they're asking for or they give us. So it says how many moles of lithium hydroxide, so I'm going to put how many moles, are required to react with 20 moles of carbon dioxide. So 20 moles of carbon dioxide, which is the average amount exhaled by a person each day. So I know that I'm going to start with 20 moles of carbon dioxide. And I need to convert into moles of lithium hydroxide. So I need what units on the bottom? Moles of CO2, and on top? All right. Now this is where, and we're in the correct units, so we can end here. Before I just told you didn't really need the compound in your conversion. But I said it's a good idea to get in the habit of doing that because now we're going to be switching compounds within our same conversion, and you need to keep it straight in your head, and it makes it a lot easier if you actually write it down, which compound is which, because then you're going to use the molar mass, and you need to know which molar mass am I using, because there's 4 compounds down there that I have a choice of. I need to know which molar mass I need to use. So it's good to have our compound formula here. Okay, when we go to mole, we use our coefficients. So we have for CO2, when there's no coefficient, that just means 1 CO2. So we're going to put a 1 here. And then lithium hydroxide is a 2. And now we're going 20 times 2 is 40 moles of lithium hydroxide. And for physics last week, Clayton Anderson was here. Do you guys remember? Do you guys know who Clayton Anderson is? Yeah, the astronaut guy. He's an astronaut. So he was talking to him about everything, and he was talking to him about water, because obviously you need to drink a lot of water, but it's hard to take all the water out and out to the space because water's pretty dense. And so they can do some conversions, like taking the gas and converting it into water. They can also, or vice versa, if they have some water, they can convert it into oxygen gas to breathe. Then he also said whenever they go to the bathroom, they urinate into a machine thing that converts that into water that they end up drinking. He says it. says it tastes like any bottled water that you get in the store. So, yeah. Obviously, they tested it and it's safe, and it's just water. I mean, it's just water at the end. So, just H2O. Just the idea of how it. But really, like Omaha, you know where Omaha gets their water? From the Missouri River. So they get the water out of the Missouri River, and that they purify it and filter it, and then they drink it. And then you know where their sewer goes? The Missouri River. So they treat it. Goes to the sewer, the treatment plant, and it gets put back into the river. And then do you know where Kansas City gets their water? Missouri River. And so, so yeah. I mean, all the cities along the Missouri River, that's what they do. They.
You ever notice how water in our area tastes amazing, but if you go to Lincoln and stuff, because a lot of them have to chlorate their water.
Did you see? It was just on the news that I think, was it Kozad? No, it wasn't. Curtis. It was Curtis. They won the national water competition or whatever. That they had the best tasting water. They tested on like clarity and taste and everything else. I don't know who judges that. It doesn't taste the same.
It's not like a taste, it's like a feel.
Yeah.
You said water doesn't have taste,
But it's the best. So what he was saying too is we need, maybe you guys can be involved in developing, just think of like in Africa where they don't have clean water. If you could somehow get one of those machines or whatever to Africa, and then they could get their clean water through that. But you need people to actually be part of that innovation to do that. There you go. I know, but I don't know. Maybe it's I don't know. I don't know why they can't just. Yeah, they probably are really expensive. So figuring out how to make it inexpensively. Okay, the disinfectant hydrogen peroxide decomposes to form water and oxygen gas. How many moles of oxygen will result from the decomposition of 5 moles of hydrogen peroxide? What do we need first? Very first thing. Yes, we need a chemical equation. So, it's a decomposition equation. What's our reactant? H2O2, and it breaks down and makes... No. Plus O2. Yep. Is it balanced? Nope. We have 3 oxygens on the right and only 2. Okay. So now we have 4 oxygens and 4 hydrogens, so good. Okay, and now how many moles of O2, so I'm going to put a little how many moles here, result from 5 moles of hydrogen peroxide. So I have 5 moles here. So I'm going to start with 5 moles of hydrogen peroxide. What units go on bottom? Moles of H2O2. And on top? Moles of O2. And 1 to 2 ratio. Use our coefficients. And so 5 divided by 2 is 2.5. Very good. Questions on that type? That's probably the most simple type. Just make sure you have a balanced equation, getting your equation balanced, and then make sure you're going straight moles to moles here. Okay, problem type 2 is moles to mass. So you're given moles like we did in the last problem, but instead of stopping at just moles of the whatever the second compound is, you're going to convert moles into grams. You're going to do one more step. We're going to use our molar mass at the end, convert moles into grams. So in photosynthesis, plants use energy from the sun to produce glucose and oxygen from the reaction of carbon dioxide and water. So we need to write an equation for that, correct? So what are our reactants? What's reacting together? And our products? And which is O2. Not balanced. So carbon, we have 6 here, so let's put a 6 out here. Hydrogen, we have 12, so let's put a 6 here. Now oxygens, we have 8 here, but we have 6 plus 12, 18 over here. So if I have 18, if I subtract out these 6, I get 12, so I can put a 6 there. So now we have 6 times 2 is 12, plus these 6 is 18. Okay, now it says what mass in grams of glucose, so we need how many grams of glucose is produced when 3 moles of water reacts with CO2. So we are going to start with 3.00 moles of water units on bottom would be moles of water. And on top, we're converting from one compound to another, so when we're in moles of water, we want to go straight to, well, our question is asking about how much glucose, so we want glucose. We are going to get to some problems where they'll throw extra numbers in there, and we'll have to figure out what's what, too. But the coefficient for water is 6, and then 1 for carbon dioxide, or for glucose. Now, we are not in the correct units yet, correct? They're asking for grams, so we need to do one more step where you say the mass of 1 mole of glucose, and how do we get that number? 6 times mass of carbon is 12 times the mass of hydrogen plus 6 times the mass of oxygen. And what is that? 6 times 12.01 plus 12 times 1.01 plus 6 times 16.
It's a number, sure.
What did you say, Darren? 48.
No.
Should be like 180 point, I don't remember. 0.6 plus 12 is 8. 0.18, I think.
Yeah, I think so.
180.18, I think it should be. Someone might want to check me. Is that right? 16. No one else has a calculator?
Yeah, too lazy.
Oh.
Calculator.
8 1 or 1 8?
Oh wait, no, 1 8. Sorry.
Okay.
Pretty sure.
So then 3 divided by 6, that's 1/2, right? 3 over 6. So half of 180.18 would be 90 point.
Or something.
90.09.
Yeah.
Yeah. Shit.
C6H12O6. There you go. So really, we've done this step before a lot, just not in sequence with these, but we've done grams to moles and moles to grams. So you should know how to do that part once you get it to moles. Next one, last one. Mass of carbon dioxide in grams. So we're using the same reaction because we're looking at photosynthesis. So let me write that back up. Okay, and so it's asking for mass of carbon dioxide in grams is needed to react with 3 moles of hydrogen. So the same amount of water, sorry, not hydrogen, same amount of water, how much carbon dioxide in grams are we going to need? So we need to start with what again? Start with our 3 moles of water. What's our first step? And so you can see it's 6 to 6. So when you put it into your calculator, do you really need to put that part in? No, it's 1 to 1. So I would leave it as 6 to 6 when you write it out, just so that way the numbers, you don't get confused where the numbers come from, but you can see right there that it's 1 to 1. That's fine. And then what's our next step? Because we're not in grams yet. On the bottom, we need 12.01 plus 2 times 16 is 32. 32 plus 12.01 would be 44.01. So we need to take 3 times 44.01. 0.53? Oh, 3. There we go. So questions on those types of problems? Okay, your assignment for tomorrow is from your book. If you have an old book, I think we looked it up. It's on page 305. So if you have an old book checked out, it'd be on page 305. This is from the new book, so right now you can go grab a new book if you want, or an old book. I don't care which book, and work on them. You'll notice that it says, there's a little box. They're practice problems in a little box. And it says right next to it that the answers are in Appendix E. So you can look up the answers to check yourself. To get your credit tomorrow, you need to have all your work shown. You can't just have an answer written down. So there's just 4 problems right over in that sliding cupboard.
Wednesday the 26th, right?